Welcome to the DIY Honda Garage channel. The DTC P2195 indicates an issue with the air-fuel sensor, specifically sensor 1, which is signaling a stuck lean condition. This means that the sensor is detecting an air-fuel mixture that is too lean for optimal combustion. The A-fuel sensor, sensor 1, is crucial for the engine management system as it helps determine the correct air-fuel ratio for combustion. It is typically located in the exhaust stream, upstream of the catalytic converter. Vehicles like the Honda Civic from the years 2011 to 2015 heavily rely on this sensor to optimize engine performance and emissions control. Understanding the DTC P2195 is essential for diagnosing performance issues and ensuring compliance with emission regulations. This DTC can be triggered by multiple factors, including malfunctioning sensors, wiring issues, or even fuel system problems, making it imperative to conduct a thorough diagnostic process. The AF sensor, also known as the air-fuel ratio sensor, is designed to monitor the oxygen concentration in the exhaust gases. It plays a pivotal role in the fuel management system by providing real-time data that helps to adjust the air-fuel mixture in the engine. This sensor is located in the exhaust stream before the catalytic converter, ensuring it measures the mixture effectively as it exits the combustion chamber. When the DTC P2195 is triggered, it signals a problem with this sensor's ability to report accurate measurements, often indicating a lean condition, meaning there's too much air and not enough fuel in the mixture. As a result, the engine may run inefficiently and produce higher emissions. Addressing this code promptly can prevent further engine damage and maintain compliance with environmental standards. Several factors can lead to the triggering of DTC P2195. First, a dirty mass airflow (MAF) sensor or intake air temperature (IAT) sensor can affect airflow measurement, causing incorrect fuel mixture adjustments. If debris accumulates on these sensors, they provide inaccurate readings to the engine control module (ECM), leading to lean conditions. Second, improper installation or a loose connection of the AF sensor can cause it to malfunction. If the sensor is not securely installed, exhaust gases may escape, resulting in false readings. Third, there may be wiring issues such as broken or frayed wires that connect to the AF sensor or the ECM. Such electrical problems could prevent the proper transfer of sensor data, leading to misdiagnosis of the lean condition. The symptoms associated with DTC P2195 can significantly affect vehicle operation. One of the most immediate indicators is the check engine light, CEL, illuminating on the dashboard, signaling that a fault has been detected. Additionally, you may notice poor engine performance, characterized by a rough idle or sluggish acceleration, as the engine struggles to maintain optimal performance due to the incorrect air-fuel mixture. This can also lead to increased emissions, jeopardizing compliance with environmental regulations. Drivers may also experience fluctuating engine speed or stalling, particularly during acceleration or deceleration. Recognizing these symptoms early can help in mitigating long-term damage to the engine and its components. In the first troubleshooting step for DTC P2195, you must perform a visual check on the MAF and IAT sensors. Begin by safely removing these sensors to inspect them for any dirt or debris that may be affecting their performance. These sensors are often susceptible to contamination from the air intake system, which can lead to incorrect airflow readings. If you find that the MAF or IAT sensors are dirty, cleaning them or replacing them as needed can help rectify the problem. If the sensors are clean and properly functioning, you would then proceed to the next troubleshooting step to continue diagnosing the DTC. The second step in troubleshooting DTC P2195 involves checking the installation of the A-factor sensor, sensor 1. This step is crucial because a loose or disconnected sensor can lead to inaccurate readings and trigger the DTC. Inspect the A-factor sensor for any signs of looseness or disconnection from the exhaust pipe where it is installed. If the sensor appears to be improperly mounted, it must be reinstalled securely. Proper installation ensures the sensor accurately measures the air-fuel mixture, which is vital for the engine management system to function optimally. If everything appears to be correctly installed, the troubleshooting process will move to the next step. In this third troubleshooting step, you will verify the problem by utilizing the Honda Diagnostic System, HDS. Begin by turning the ignition switch to the on position, 2, ensuring that all electrical systems are powered up. Next, clear the stored DTC with the HDS, which resets the fault memory. After clearing, start the engine and hold the RPMs at 3000 without any load. This is critical as it allows you to see if the system can maintain proper function under these conditions. While holding the RPMs, pay attention to any pending or confirmed DTCs that may appear on the HDS. If DTC P2195 reappears, that indicates a persistent issue that needs addressing, particularly checking for poor connections at the AF sensor and the engine control module, ECM. The repair verification step is essential to confirm that any corrective actions taken have resolved the issue associated with DTC P2195. Start by turning the ignition switch to the on position. 2. To activate the electrical systems. Use the Honda Diagnostic System, HDS, to reset the engine control module, ECM, or powertrain control module, PCM, ensuring that any learned data or fault codes from previous tests are cleared. After resetting, let the engine idle without any load until the radiator fan comes on, monitoring the OBD status using the HDS. Observe whether the HDS indicates passed, failed, or not completed. This status will tell you if the repairs have been effective or if further troubleshooting is needed. In the final repair verification stage for DTC P2195, it's crucial to evaluate the results from the HDS after the repair process has been completed. If the HDS indicates a passed status, it confirms that the troubleshooting steps resolved the issue. In cases where the ECM or PCM was substituted or updated, be sure to replace the original component once verification is complete. However, if the HDS shows a failed result, it requires a recheck of the troubleshooting steps undertaken. Should the HDS indicate any additional pending or confirmed DTCs, those should be addressed according to their specific troubleshooting guidelines to ensure the complete resolution of the vehicle's issues. In conclusion, understanding the role of the AF sensor is key when diagnosing DTC P2195. This DTC signals a stuck lean condition that can significantly affect vehicle performance and emissions. By following the outlined troubleshooting steps meticulously, you can accurately identify and resolve issues related to the AF sensor, MAF, and ECM connections. It's also essential to verify the repairs through OBD status checks to confirm successful resolution. Timely intervention not only prevents possible engine damage, but also ensures compliance with environmental standards. Always maintain a diligent approach during diagnostic processes to promote optimal vehicle operation. Please like and subscribe to the channel. See you next time.